this is our final class, last class before your final exam. So your final exam, the schedule has been released, right, by the BPA. The screen, your final exam is on 25th, right? 25th of January, 9 a.m. Face to face, right? Your final exam is face to face, huh? So the question is quite similar with the previous semester. So I have discussed in details the final exam. So today we will look at the how we want to uh, program differential evolution using MATLAB. Okay. So I will. So let's take a look at step by step. Because this algorithm that you need to use in your assignment. Okay. So your test is 30%. Your assignment 15% and 50%. So 30%. So final is 40%. Okay, so we start our differential evolution. Just want to recap. What is differential evolution? Basically, it's quite similar to the genetic algorithm, but it is not related to the binary representations, and it uses real number strings, so we don't need to encode and decode. Okay, this is the differences between ANN and GA and differential evolution. Okay, basically this extension. So this is our parameter or our variables. So we want to use the differential evolution to be applied at distributed generation problem. Okay, so X is our variables, consists of our I represent your how many your variables. So let's say we want to find one DG to be installed, in system, in the power system. So we have two variables. Number one is your location. Number two is your size of your DG. Okay. And then the important thing is your evaluation functions. So this one is depend what is the objective that we want to solve. Okay. So DE consists of 3 steps: mutation, crossover, and selection. So we will look at this in details later. So because we have discussed this example previously. Okay, so start. If you have your MATLAB, you can open your MATLAB. You can do it together. I think I have shared the file. Saya dah share belum? Dah kan?
Kalau siap boleh.
Share the DE file. The program that I obtained from this book. Mana e-book? This from this book. Okay, so there is a lot of algorithms. I think they just GA they didn't share, but I think the differential evolution have. So this is the differential evolution, and then the the authors give the pseudocode as well as the program. Ada tak? Kalau tak ada saya dapat mana? Tak ingat. Ada ni. So basically this one you can obtain the program from this book or from the MATLAB sharing file. Okay. So basically we want to learn how the problem is the program is there. So we want to use the program to solve the power system problem. That's the important. Okay. Saya dah share belum? Dia punya solution apa ni?
Yang ada 6 file ke? Ada 6 file, ada 5-6 file tu share last class.
Saya share ya.
Yang Elga,
Bukan. Itu GA ya.
GA kan?
Rasa tak ada lagi, Doktor.
Tak ada lagi ya. MATLAB ni GA kan? Ni lah MATLAB program ni. Ada BMO lah. Macam mana BMO lah ni? Okay, tak apa. Ni lah. Buka jap.
Tak ada lagi.
Ya, tak apalah. So, I share the file ni. Okay. So if you have the file, I just share. If you have the file, you can open. You open your MATLAB. Okay, you open your new script. It depends on your MATLAB, but sometimes when you you have the recent MATLAB version, some of the functions sometimes is obsolete. So you need to check whether the program can be executed or not. So you just open. So let's start with the init 1. Okay, so we just do is step by step lah, one by one. So in order to make sure that you can understand from the fundamental until how we want to use any program that has been implemented by people, by researchers, and they share the codes, so you can get the codes and you can solve your problem directly. So there is tips and tricks. So let's take a look at this slide. Slide saya dah upload I have uploaded the slide at the Kalam. So first thing to remember, this is the steps. Okay. Number 1 is your initialization. Initialization, any optimization problem or optimization algorithm, you start with initialization. And the beauty of the algorithms or nature inspired algorithms, that normally they start with the random number and we solve in the population. Okay, so in population base, we're not a single agent, we just use a population base. And then the most important things that you need to do, or if you have developed any solution, let's say you have developed using GA by using the program. So this is the function that you need to develop. in order to make to apply any algorithms available in the website, you can apply. So this is the fitness or function or objective function. So it can be a single mathematical equation. This one is a simple, or it can be a set of subprogram or subroutine, or it can be a function that I share with you all. Sometimes you use toolbox. So I normally use toolbox because power system we have toolbox. Okay, we have Math Power. This one you can get directly. Math Power, and then sometimes Hadisadat also have develop the MATLAB program. So these two basically is the famous one, because this one is can use to solve. Normally we use load flow program. So it is very compatible with your problem in power system. And Math Power is has been proved that can solve pollen system. Okay, until I think more than 1,000, I think 4,000 something bus. Okay, for verification you can use. But until as far as I'm have experience in developing the solution of the power system, normally we just use until maximum is 300 bus. 300 bus is normally for PhD level. For master level is 118 is I think is quite high already. Okay, no problem. That one is IEEE system. Okay, and then this is the operator of DE, mutation, crossover, and selection. So we will cover these things step by step, one by one today. So normally this file I share with this is a workshop, how we want to use optimization problem to solve the power system problem, optimization technique to solve power system problem. So this slide also is, I think it's old one, it's 2012, 2013 gitulah. Okay, so we want to use the DE to using MATLAB. So we start with the initialization. So basically the syntax in MATLAB, you can directly just give a number, just give a simple coding. X1 equals to random XY. X is your row, Y is your column, and then you times A plus B. A is the offset, B is the minimum number. So let's say you have for the variable number 1, you have, let's say to solve DG, we have, let's say we want to install 1 DG into the system, into the power system. Normally in terms of distribution system, we want to install 1 DG, so we have 2 variables. It's a location and as well as size. Okay, so your location basically, because normally in power system distribution, bus 1 is the slack bus. Okay, so you have, let's say you have a radial system, you have bus 1. Bus 1 is your slack bus or generator bus only. So normally your minimum value is, you don't need to install the DG at bus 1. Okay, so normally your location is between 2 until, let's say you have 69 bus, so meaning that you have this range. Okay, your minimum value is 2, number of bus number, and then 69 is your maximum number. And then your size. So size basically you can refer to any paper. Normally they start with the 0.01 megawatts until 2.5 megawatts. Okay, the size to get the optimal value. And the objective, your objective is what? For DG normally we have several objectives, but for simplicity we just use to find the minimum loss in the system. Okay, so this one is an example to generate one random number between 10 to 25. So your output is your X, equals to random 1 times 1 because you have just a simple one number, 1 times 1 matrix, times 15 because the offset is 25 minus 10. So if DG is 67, this one, right, the offset, and plus 10. 10 is the minimum number. Okay, so if you open the file, init one, this one, sama kan, clear random 20. So this one, init one, if you open the file, init one. So this one we want to, this is just a simple coding. Okay, clear is to clear the workspace, CLC clear the screen. Okay, x1 random 20 meaning you have 20 row times 1 column. So matrix 20 times 1 and matrix 1 times 20. So if you run, okay, kalau tak nak run pun, if you don't want to run, you just select, you can evaluate, right click, evaluate selection. So we come like this. If you open, this one, the value of x1 is stored into the workspace. So if you open this one, you have x1, x2. So you can double click. This is your x1. x1 meaning that you have 20 times 1. You have 20 variables times 1. x2, this is x2. When I didn't put the semicolon here, it will printed at the command window. So this is x2. 1 times 20. 20, one column, one row, 20 column. Okay, this is the how we want to, and you can see that your value here is a random number that consists of between 10 to 25 because you want to find the between 10 to 25. Or you just can use loop. Kalau you run, dia akan ada error ataupun you kena tukar lah. Tadi I just evaluate, right? So you can, if you run, you need to change folder. Change folder, dia akan keluar macam ni. So this one is your x2 tadi. Your x3, because I didn't open it, this one. So this one. This one is if you want to using loop, using for and n code. So we have n equals to 1 until 20. So you have 20 20 numbers. You want to find the 20 random numbers. Random, this one is just a random. It should be a random number times 15 plus 10. So you can type x3 like this. If you put this here, this one, if you open the semicolon, it will print one by one x4, right? So you can get the result like this. That's why it's start from 1, 1, 2, 3 until 20. Okay, and the value here, the value is between 10 to 25. Okay. So this is example. For sure, the result is different because it depends on the random number. So the result is different with the slides. Okay. But the one thing is for sure is your results obtained is between 10 to 15, 10 to 25, right? 10 to 25. So your result is between 10 to 25. So this one is just a simple. So let's take a look at the example. If you want to initialize and do the evaluation, this one is simple evaluation. So we have your x. This is your x, your variables. This is your output. This one is your variables. So this one we have one variable only because we have one only. So our variable is x, and the output is y. So you can open, I think this one init 2. Init 2. So right. So this one. So you have x1 equals to random 20 times 1. You have a 20 column, 20 row, 1 column times 25 minus 10. And then we want to evaluate. So this is how I program. So you can select, you can run, or you can evaluate one by one. Okay, we have negative value there because of we have minus, because our minimum value is minus 10. Okay, so your result is between minus 10 to 25 or to 15. Minus 10 to 15. So it will not exceed 15 as and minus 10. So how you want to evaluate? So basically I use this function zeros, meaning that what is meaning by zeros? You can type help zeros. So zeros is a zeros array. It will ready for you for matrix. How many matrix that array that consists of zeros numbers? Okay, so let's say we just copy this value y equals to zeros. You can copy or you can evaluate. Simple. So it consists of 0 value into metric 20 times 1. Okay, because basically it's not this is the proper way in order to minimize the memory usage of MATLAB. Okay, you prepare, if you learn about the microprocessor in your undergrads, normally all these things require memory to store. Okay, so this is one type of how you can we ask MATLAB to prepare the location or the buffer to store the results here. So this is your y, consists of zeros value of matrix 20 times 1. Then you can run one by one. So this is our y. K, this is how we program one by one. So this one is y, this is row k is 1 until 20, right? So we have 1 to 20. So we have x 1 to 20. So you should run this thing. It will input all the value here. This is your x. You can verify, but I think this is correct. So when you have x 11.3258, the output is minus 15.0155. Okay, because we use this equation. X number 1 times 10 minus x square. Okay, that's why you get the value there. So this is how you obtain the results, the output. Okay, so this is a simple initialization and evaluation. This one, initialization and evaluation. This one is example. So when we use the Hadi-Sadat, the diffusion evolution program, so we can use Hadi-Sadat log flow program, or you can use any log flow program to solve the problem. The result may varies, but the location I think should be you get the similar results, but the value of size may be quite vary, and the losses also. So for digit allocation problem, we have parameter that, as I said previously, or variable size, not parameter, is variable. So it's bus number and the size of DG. So we have IEEE 69 bus system. This one is the well-known system. Distribution, don't be confused with the transmission system. This is distribution. So undecided load flow program is used as function evaluation, where the fitness or cost function is to minimize the total system loss when we store DG at any bus with the optimal size simultaneously. So this is the 69 bus. So as you can see, there is one substation. Basically, one substation. This one is we have one generator. So and then we have 2, 3. This one is radial. Look like radial, right? So everything is radial. So the system, you can see, you can open at here. If we have bus 69 PU, this one is the name. Okay. So this is the input data. So consists of bus data and line data. So bus data is number 1 represent the slack bus. Right now, this one, the first row, the first column is your bus number. Second column is your bus type. So this one represent slack bus. 0 represent PQ bus, because we have only one generator. So only one is slack bus. So the rest is, the code is 0. Okay. And then this one is, I think, the voltage, I think, and then this one is a load. Okay. And then for line data, this is your line from and line to. Meaning that 1 to 2, 2 to 3. So this is a line, transmission line notation from 1 to 2. This is your R, your X, and your your susceptance, as well as your transformer tapping. But the system distribution don't have any transformer. Okay, so this is a system. So you can open init tree. Okay, so this one is, so we can use this thing. So this is what we have to do in order to solve the DG problem. So first is initialization. You can use the function here. Okay, and then we have our boundaries. This is not parameter, this is our variables. Variables meaning that our X. So number 1 is your minimum bus. Number 2, like I said previously, and then your maximum, your minimum size of DG is 0.01 megawatts, and your maximum bus is 69, because we have 69 bus, and then your maximum size of DG is 2.5 megawatts, meaning that then this one is not parameter, variable. Variable dimension D equal to 2, because we have location as well as size. Okay, and our population is 20, so meaning that your X equals to, this one is 20 times 2. 2 because our D, location, size. 20 is our population number 1, 2 until 20. Okay. So this is you can use for initialization. Okay, we just go for the MATLAB program. So we have LB is lower bound. So minimum bus number is number 2. Your upper bound is 69. 0.01 is your value of size. 2.5 your maximum value of DG. So our D is 2. Okay, length of LB or length of UB is 2. And then we have our population number is 20. And then you can use RipMat. RipMat you can type here. Help RipMat is a replicate tile and array. How? Because we want to make sure that our calculation is simple and don't have any problem. So we can use, this one is your range and this one is your lower. So if you put this value and then you can run if you do evaluation, so we can see that our result is like this. This is your X, this is your X1, your bus number, and this one is your size. Bear in mind that now basically your location, it should be discrete, right? Discrete value, but now is in floating numbers. So later we will cater these things. Okay, so this is your X value. You have 20 population, 2 variables. Number 1 is location, number 2 is your size. Okay, location between 2 to 69, size between 0.01 to 2.5. Okay, this is our X1, X2. But our problem is our location is in floating numbers. Never mind, we can skip here first. And then we want to allocate our Y or our fitness value. So our fitness, we just evaluate the fitness. So 0, because we just prepare the value, the 0 value into this matrix. And then we want to evaluate. So how we want to evaluate is you can use this function. You call the function for data, 69 bus. And then bus data, this one is how Adisadat is programmed. Okay, you need to change the value. Okay, you need to change the value. Okay, fitness using Hadisadat load flow program. We have our X just now, right? So our X is 20 values, and we have some value here is a floating numbers. So we want to make sure that this value is supposed to be discrete. So you can decide by whether you use floor or ceiling. Floor meaning that, let's say you have 64.34. So when you use floor, 64.34, it will select 64. Okay, you can use floor or you can use ceiling, S-I-L, C-E-I-L, 64.34. When you use seal, it will choose 65 because we took floor is the lower value, floor is the higher value. Or you can use round. So round the numbers. It's less than 0.5 should be 64. More than 0.5 you get 65. So I select floor. Okay, and I need to put this value. So let's say our example here, our first value is 54, right? So it will choose 54. Value is the 54 because it's the floor. And then Mak, kan ya? Yeah. So you choose 54, and to put this value, this size into the bus number of 54. So what we can do here, basically I put this value, your bus data, when you just change the value is bus data 54.7 equals to XKK2. KK is from 1 until population. So KK2 meaning that is your number 1 and number 2. So let's say this one is 54, right? This one is how much? 1.3721. This one is 1.3721. So I want to put this value into bus number 54.7. So if you look at your MATLAB data, 54.7 is here, 54. and then I put value, no, this one, bus data, right? So 54. Row 54, column 7. Column 7, 1, 2, 3, 4, 5, 6, 7. So this value is your generators, generation numbers. Okay. So this is column 7 is generation numbers. So I put this value 1.7, 1.3721 to bus data, because this is our bus data, row 54, column 7. This one is your load. You didn't change the value. This one is your generation data. This is load data, generation data. Next, since we have installed this value and we choose this value as a PV bus. If you remember, if you learn about the load flow, you have slack bus or reference bus. Slack bus, normally bus 1 lah. And then you have PV bus. And then you have PQ bus. PQ bus is load bus. PV bus is your control voltage. So meaning that this one is generation data, generator bus. So when we select bus 54, meaning that we need to change from 0 to 2. Like I said previously, 0 represent of PQ bus, 1 represent slack bus, 2 represent PV bus. So at 54, 2, I need to change the value to number 2. Okay. So this one is insert generated bus number to bus data with size of DG at each population and change bus type to PV bus. This one is changed to PV bus. Next, Hadi Sadat will construct the load Y bus and then solve using the Newton-Raphson method, and then this one is just printed. So this one you can calculate fitness for this value is how many the SLT. SLT represent of number of represent of the loss, total loss. Okay, so you can open this value. So we have LY bus. This one is MATLAB programmed by Hadi Sadat to obtain the Y bus to calculate the load flow, right? And then you have LF Newton to solve using Newton-Raphson. Then this is a line flow to printed, and then SLT is your real power loss here. So this one, the value that you want to capture. Okay, so if you run init 3, if you run, it will run 20 times until 20 times because we do the initializations. So this one you capture the value of system loss, and then you can find this one is the best, and you can obtain this value. So let's run this program. If you run, it will run for several times. Okay, this one you can open, you can close, or you just leave it here. So this is how the Hadi Sadat. So and then we capture the value. This is the value, because I just run again, because and then your X is different. So this is our results for the initialization. Okay, Y is the output, X is my input, your bus number and location, and my fitness is my real power loss. So this is the value. So this one is the best value. So far, for initialization, this is the best value. Which I need to install at bus 45. The value of X is the value of size of DG is 0.7846 megawatts. And this one is your loss, 0.2316. Okay. If you want to know the best results, you just type best. This one best. So the best is at bus 17 0.7487. Bus 17 yang mana? Yang ni. This one. This is the best solution so far, because you get the minimum loss 0.1861 megawatts. So this is the evaluation. The evaluation using program or using subroutine, okay, or functions. Okay. One just a simple hadis adat. So this is my results when I run during doing the slides. Okay, when I prepare the slides. So at that time. So this one your F min and best. Okay, bus number. This one the DG size. And the best solution initialization so far. Okay, this is evaluation function. Or you can create the function. We create the function the name is fun. When you do the function, when we create the function, your function name must have name, and this one is your input. Okay, this one your output. This is how we create the function. So let's say I just give the number is fun. So you can open the function fun. This one. So fun x. This is our input, and output is z. You just copy everything from the initialization just now here and put into this, becoming the function. This is the function. You call the data, you obtain which generated numbers, okay, and then just call the undecided function and give the output. The output is a real SLT, meaning that the real value of loss. Okay, then you can get like this. Okay, this is called function. Okay, if we give this you go in H4 fitness KK fun X KK, you just run the similar value, you just run. If you run, you give a similar results. Okay, so you guys call the Y X fitness best. Okay, plot best for Y. So meaning that your current for the initialization is 55. The value is 2.28. Okay, so bus number 55, this one. This is the current solution, best solution. Okay. Any question, class? So this is how we do the to solve the DG problem using DE. No, this one is just a simple initialization. Okay, remember initialization is this one, initialization to generate random number and do the function evaluation. We just complete these two steps. So now we want to enter the DE. Okay. Okay, so now we start the DE. So how we want to start the DE? We just call the initialization script. This one we use script. We just call init4. And then this one is the set by the program of DE that has been developed by Yang. And then you need to set your F, and then your CR. CR is your crossover parameter. And then we set the maximum iteration is 50. Okay. Then you can open the file of DE. So this one start from the initial iteration. While the iteration less than max iteration, your max iteration is 50 iteration, right? 50. So this one is just how to obtain the donor vectors by permutation to see the random use the DE function. So we can use a random permutation. So what if random permutation? You can type here help random permutation, random. Okay. It will give you value like this. Let's say you have population, you have 20, K1 and K2. K1 equals to random 20. You get this value. Let's say you want to K2. It will give you random numbers, random coordination. So this one, random 20 values for K1 is 14, 1 until 20. So basically it's a 20 numbers, 1 to 20, but it's a random fashions. Similar with the K2 also, we give the random values. So this one the properties of this random permutation we use in the DE. Okay, and then if random crossover matrix less than that we have set it 0.9, so we find the donor vector, this one. Okay, so this one you can see at the equation 6.3 in the books. Okay, so how you basically these two equations is, you can see it is like the visualization is like this one. Okay, how we want to do crossover, whether we want to maintain or to use the vector and trial vector. Okay, and then you evaluate. This one, it will create a new solution. It will change the value of your random number. Just now, let's say your random number, your X is 54, 1.5 something, blah, blah, blah. So it will change each of your values by using this equation. Then we need to evaluate everything. We need to evaluate using this equation, and we need to check whether is it out of bound or within the bound. So this one, we need to change our value here. Is less than this bounded value, is we select the bound value. Let's say when you do this function, this evaluation or this program, your value X becomes let's say your location becomes 1 point something, so you select 1, right? So this is not correct because your minimum value is 2, so you change back to the 2. Similar, if you are out of bound in the upper bound, let's say the value of your value is 2.5 2.6, so the algorithm or this program is really make sure that your value is within the bounded value, is maintained at 2.5 megawatts. Okay, and then you need to evaluate. We have developed our function just now, fun. We can use this thing. And then we want to find that our solution is improved or not using this function. And we want to store or update the current best value by using this function. And then iteration equals to iteration plus 1. So exit from 0 to 50 iterations, and then you can stop. Okay, this is example you can look at here. So you can run your, this one init 4, you can run your, I think MyDE, right? This one MyDE. You open MyDE, this is initialization number 4. Init 4, we just call the initialization. We set max iteration, this is the function, and then you can run. If you run, you need to wait for a while because this is our function, because we want to run until 50 iterations. Okay, depend on your computer. So when you do the optimization, normally this one is quite simple, 69 bus. So during MCO last time, I'm using 118 bus. Okay, so it plot here, your DG location is bus number 61. Your DG size is 1.8394. The minimum value is 0.02316. Okay, so this one DG location 61. So you can verify with my paper lah, because lama ni paper. Okay, this one. Okay, cuba tengok paper ni. Alamak, tak boleh. This paper tahun 2012. This one I use Firefly. Similar, I use Firefly. I obtained from the Yang book that written by Yang. Tengok result dia sama, sistem sama, 69 bus. So case 1, distribution of loss and minimum voltage before deviation. Ni case 2. Ni saya guna 2 DG. Kalau 1 DG. Case 1, calculate distribution losses minimum voltage before DG. Case 2, repeat case 1 with 1 DG. Okay. This result. Okay. So the result is quite similar lah. This one, suppose memang kalau you run mana-mana algorithm pun dia akan dapat bus 61. The value of size is depend. Bus 61 with 1.8753. So I got, okay, this bus 61, the size 1.8 something, quite close. Okay, this is the example. Okay, this paper has been published in IEEE Explore. So basically, this is how I hope that your second assignment you can use, you can submit your assignment like this in terms of paper. So you can refer this paper for your assignment. Start with your introduction, start with your algorithm, and then followed by algorithms, and then algorithm applied to the DG problems, and then you can put flow, and then you put your results. Okay. So we have done this thing. If you run again, similar guide, you get supposed to be get 61, but depend on your initialization. So sometimes you can get, so that's why in optimization you need to run several times. So normally you run 30 times to get the, to make sure that your result is consistent. Okay, to make sure that your result is consistent, normally we run 30 times at least. Okay, so then you can get many data or many results to be presented and to be analyzed. So if you run again, let's run again, supposed to get the similar results. Kalau tak dapat, if you don't get the similar results, meaning that the algorithm is not so robust, not robust. Okay, this one is 50 iteration only. Okay, you can use many analysis. So as you can see here, we have case 1, and then we have case 2, and then we have case 3. Case 3 is we install 2 generators. So that is your assignment. How we want, if we want to install 2 generators, how we want to do this. So similar. So the result is similar, 61 DG, 61 bus number location 61. Your size is 1.383, and this is your loss. So basically DE is quite good because there is a lot of researchers have been using DG and they improve the DG, because DG, as you can see that in the notes, that DG have many variants. We look at this book, right? So there is a lot of variants that can be explored. This one. Okay. This one, convergent analysis, choice of parameters. You can use F, any value. You can choose F0, but the good one is this one. That's why I choose 0.7 and 0.9. You can play around with the value parameters, and then it has many variants. So we use the variant yang ni simple. We use the basic DE random 1 bin binomial using this value. So you can use any variants. So if you're really interested in studying in optimization, you can use any variants, because one of the researcher that I refer, you just play around with the variants and get a good result and can get PhD and solve the power system problem. Okay, so this is a lot of variant. So normally in your class we just cater these things, the basic. Okay, this is a simple with the iterations. This is the output, bus 61, 1.8 something. This one is your objective function, your loss. Okay. So most studies have focused on choice, FCR, and population size, as well as modified the mutation equations, like I said previously. So we can use many different way. So you can use many different way that you can apply in your assignment. Okay, this is the basic. Okay, and you can get all the various algorithms that you can use in file exchange. You can type this thing, or you just Google it. Okay, one thing remember, if you have any algorithm, you need to see how the program is being done, and you need to suit your problem with the toolbox or algorithm that we want to use, that have been proposed by the researchers. Okay, so I refer this book, so you can get the book online or offline. Okay, class, any question? Any question?
Assignment 2 ni due date dia bila?
Yep. Angah?
Due date for this
Due date bila? You all punya final 25 kan? Lepas final pun tak apa. Akhir bulan lah. 31 lah boleh?
Okay. Cantik lah.
31 So I just upload, I bagi je terus assignment tu kat sini. Nanti saya upload dekat Turnitin dan juga Kalam. Your assignment tu. Bukan. Sekejap. Assignment tu tak ingat yang apa buat ni. Oh, assignment tu itu diorang buat ni GA. Lara. Ya, you all assignment 1 itu buat apa? Tak ingat. Assignment 1 you all
AI.
ANN kan?
ANN.
So assignment 2, so saya bagi awak ni lah. I give you freedom. You can use you can use GA or differential evolution to solve whether DG or economic dispatch problem. Up to you. This one kalau you use you want to use economic dispatch problem, you use type power system for the generators. Tak payah, kita buat. You nak buat economic dispatch ke nak buat DG?
Economic dispatch.
DG.
Okay, up to you lah. So kalau sama lah, you need to choose lah. Salah satu lah. Tapi nak buat dulu boleh juga. Nombor 1, choose one lah. Kalau nak buat yang satu, you guna type power. You can use GA or DE. Kalau you nak buat if you want to use DG problem, so you boleh pilih juga. Boleh, salah satu lah. Due date 31st January. Boleh. Choose one lah. Kalau you nak buat DG, if you want to use to solve economic dispatch problem, use type power 40 generators. If you want to solve DG problems, use 69 distribution system. Boleh ya? Kejap saya ada tamu. Kejap. Thank you. Okay, sorry. So any question, class? So you can choose whether to, basically you just a simple, if you want to solve the economic dispatch, you can use the GA or you can use DE. Similar with the this problem, basically you can use but if you want to solve DG problem using a DE, so I just follow my paper, this one. This paper. I just show you one, if you want to install one DG, right? So you can use analysis until 2 or 3 DGs, up to you. Where's the paper? Oh, this one. So like I said previously, you can use this paper as your reference. So how you want to develop or to solve the problems. Okay, so you can replicate back what I've done here. So I'm using Firefly. So basically, it's quite a similar program. You go for Firefly algorithm in MATLAB. Basically, you can get by Yang, similar. I think this one has been developed by this one, Yang. Get this value right. So if you download it, alamak. Ingat lah, pakai apa itu. Okay, apa? Kan. Macam mana download lah? Saya tak ingat saya ada file dulu ni. Terayu ke UMP? No, not UMP. Barakallah, agak. Forgot password. Submit. Okay. Masuk tak? Okay. Ingat. Okay. Download. Keluar lagi. Kita cuba lagi. Okay, we'll download. So this is how you can apply any algorithm. So this one, you can open this value, this file, copy. You can put at your similar folder. Oh, this one. Paste. Okay. So you open your MATLAB. So you can use any file. This one is fmincon, but the program is different, or the program is slightly different with my program. So you can choose any. This one is the, if you never know how the algorithms work, but still you can use to solve your problem. Okay, this one is one example. Let's say I never know how to use the Firefly, but you can identify that the one that you can use. This one is your para meaning n is your number of population, and iteration is 500. Alpha, beta, min, and gamma is the variables of Firefly. So you never, don't change it. You just want to show. You just want to use the program. You just want to use the program to solve the problem. So this one you no need to change, but you can change in terms of this value. So let's say we want to have similar value with this. So we have 20. So you just put 20. Your iteration, you just put 50 similar. And then your lower bound, you just change to similar value. Your lower bound is what? This one is LB. Init 3. This one, right? Copy this two. Show your lower bound, because this one you have several value. This one is three parameters. So we just want to use 2. It's 2 and 0.01. This one is 69 to 2.5. Okay, the rest no need to change, but the one that you need to change is your Z. Z cos X. So this one we have inequality and equality constraint. I think this one you can skip. So this one your Z, what is our function number is fun, right? So you just change to follow these things, fun. You try, maybe you have missed error, but never mind. Fun X. Z fun X. This one on it. You can delete or you can put this one also. You can put your comment. I think we didn't use that things. So the rest no need to change. Try to run. Whether you can get the result or not. Change pass or add to pass. Error. Not input argument. F handle U 9228. Dimension objective function handle. F handle. No, I think this one on it. This one is the equality constraint, right? So you can, because we have constraint in terms of make sure the Firefly within the bounds, objective function, D dimension. So this one you can cancel, run. Error. Too many input argument. Oh, dari benda tu. F handle, non handle. Change. Ya, itu parah. Ya. Fun handle, non handle, NSI. Evaluate the solution. Dimension function. So this one, I think we need to use this thing. Stack handle U. This one non-linear, non-handle. Equalities whole, no need. Handle U, I think no need. Apply non-linear function Z fun. So yeah. Some of them you need to choose to evaluate. This one Zn fun. Oh, okay. They also give the name is fun. That's the problem. Fun. Yeah. Need to check. Supposed to be not just run. Okay. This one. This one is using Firefly. This one no need because we don't have any equality inequality constraints. We just want to evaluate. The irony is the name function is similar, fun. Supposed to be Z and I. Where's your Z? This one, fun, cost. Okay, tengok jadi tak? See? The best solution is 61. Bus 61, the value is 1.83. The best objective is 0.03. So you can use also any algorithms. So the most important thing that, like I said previously, you need to make sure that your problem is similar with this question. So we just embed the full program into the algorithms. Okay, so any question? So that is what you need to do in your assignment number 2. If you prefer to solve economic dispatch, you can use GA. Tapi GA dah buat lah kan? Tukarlah. If you want to use to solve GA economic dispatch, boleh lah. You can use any program lah. You can use GA or any program. Any algorithm. Similar with this one. Okay, boleh buat? Any question? So assignment number 2. So you need develop, analyze, evolution programming. So you can use to solve economic dispatch, or you can solve DG. So if you want to use DG, you can use this paper as your reference. Mana tadi? My paper. Okay, or kalau if you want to use economic dispatch, so I also have economic dispatch problem solution. This one I use my Barnacle. This one Mosflame, you can see also. You can use this as your reference. What I mean by reference is the construction of your paper or your assignment. Okay, start with introduction and then followed by problem or algorithm. Never mind. So this one is start by introduction and then your problem. This one is economic dispatch. Okay, and then your algorithm that I want to use. So for your case, maybe you can use GA or DE, and then all the information, and then how you implement your problem, your algorithm into the problem, and then discuss your results. Okay, this one have meaning that in your assignment supposed to have the flow, the algorithm, initial algorithm, the equations, okay, the background problem. This one is a literature review, this one. Okay, you cite all the related papers, and then this one is your problem, what is your problem is all about, and then this one is your algorithm that you use, and then this one how you want to use the algorithm to solve the problem, and then your results. Okay, this is your results. So for economic dispatch, you can use until 40 generators. This one is 6 units and 15 units because this one have loss, but up to you. So details, and then you give your plot. This one is convergent plots, and then this one is your, you run how many times, 20, 30, 40 times. This one agents for 30 free running simulations. Okay, and then conclusion as well as your reference. So similar, this is one example for economic dispatch. This one is 2018. This one is example for solving the optimal dispatch distributed generation. Okay, similar. The concept is similar. The construction of the assignment or your report should be similar. Start with introduction, and then algorithm or problems. This one algorithms first, and then how algorithm to be implemented into the problem, the flow, okay, and then result and discussion. Boleh? Okay, class? Any question? If don't have any question, so we can stop here. So your final exam on 25th January, 9 AM, I think face-to-face, right? Face-to-face at FTKEE. So I will be the invigilator. And then your assignment, 15%, assignment 2, I will upload later, Kalam, as well in turn it in. Okay, due date until 31st January, because I need to submit your marks, I think, on February. Okay, any question? In terms of your test, your finals should be quite similar to your test lah. Lebih kurang.
Prof.
Yep.
Final open book, close book.
Final close book.
Close book. Okay, thank you.
Okay, soalan lebih kurang macam soalan test dan juga macam soalan final yang sampah lah. Saya dah tunjukkan. Okay, so if you don't have any question, we stop here. You can refer back to this video. I will share the link later for your assignment, especially for your assignment. Okay, and your assignment, I'm not limited to these 2 algorithms. You can use any algorithm. Just I show you just now how to do the Firefly, and basically there is a lot of algorithms. you can use to solve the problems. But the results, you can benchmark lah. Let's say for this one, right? So the result should be, if you solve one generator, should be bus 61. And the value should be this value, the range. And you need to, ambil credit card. Tak ada. Okay, and then until if you want to solve this, until you need to use 2 generators lah. The example that I showed just now is 1 generators and 1 location, right? Location and generators. But now you have, if you have 2 generators to be installed in the DG problem, so this is the benchmark, bus 61 and bus 67. Okay, so this is the objective function lah, 0.057. Suppose when you install more, you can lower the real power losses more lah. Okay. If you don't have any question, I think that's all for today and for this semester. So anything you can ask through WhatsApp, through our group. Okay. I think that's all for today. Okay, final, any question? All the best for your final. The final should be, I think, not almost the same, but lebih kurang sebenarnya. Okay. And I hopefully that you all satisfied with your test results. Semua okay kan? Results, test. 50% saya dah upload dah. I have upload your marks in Kalam as well in IMS. You can check. Okay, any question?
Thank you, Doctor.
Okay, no question. Okay, Assalamualaikum warahmatullahi wabarakatuh. Later I will share the video. Thank you very much.
Thank you, Doctor.